So thanks for joining. Today on our Munch and Learn, we have two speakers, Ted from HPE and Sumer Johal from who's the AgStack founder, and he'll explain this in just a minute. The subject of the session today is why open source is more than just software, and the example that we're going to take is about the Linux Foundation AgStack project. So before we do that, let me just remind a few things about the developer community. We provide these Munch and Learns, and we have a catalog of the upcoming sessions and on this page here, and my colleagues will cut and paste the links in the chat so you can just use those links. And in this page, you will find not only the schedule for the upcoming ones, but also the replay for all the sessions that we run in the past from our YouTube channel. So you can take a look there. We also have a different type of sessions that we started early this year, a little more focus on projects and products. In most cases, open source. We had already sessions every month since January on Quarkus delivered by Red Hat, or on OPA delivered by Stira. We just signed up a session for June on OpenSearch by AWS. And next week, we have a session from the Determine AI team on Determine AI. The title is not exactly this one, but you can find that on our meetup calendar there, where you have all the registration links plus the replays. So take a look at those. These are called Munch and Learn. So if you want a little bit of fun while listening to Ted and Sumer, you can share with us your munchies. And we have a couple of ways to do that. We have a Slack channel. You can join the Slack and dump a picture there. It's easier with your phone, I have to say. Or you can do that on Twitter. And if you do, you can use the Twitter, the hash HPDev so we find you. Okay. So with that being said, you can find all the information about the dev community on hpdev.io. You can scan that code to get to our community page as well. And with that being said, I would hand over to Sumer right now and Ted for the rest of the session.
Well, hey there. We've got a little bit of flicker on Sumer going there, but we're here to talk about open source, and we're talking about an unusual kind of open source today. Open source is something I've been working on for a long time in the traditional sense of software that people develop and then allow other people to use very liberally. But Sumer, what we're doing at AgStack is pretty different, right?
Yeah, so thanks for having me, Ted, and DDA and the HPE community. Yeah, it's been a really interesting journey. I approached this from a systems engineering point of view, and I wanted to develop things that could help the agriculture community. So I wasn't thinking in terms of classic software as open source, but as Ted and I started talking about it, we realized it's really much more than just software. We really want to provide a whole host of useful, actionable tools. And software is one of them, but not the only one. So it's been a really interesting journey so far, yeah.
And so a lot of people think of agriculture as somebody goes out in the field and grows some plants and harvest them, and then suddenly they magically appear in the store. But in a modern world, it's not like that, is it?
Yeah, so agriculture is a very interesting area. It's a hyper-connected constellation of stakeholders. Really, from I grew up in an ag family in northern India, where agriculture is what we would call subsistence agriculture, and now I live in California, where it's sort of very different specialty agriculture. Both are quite different from the industrial agriculture in the Midwest. So there's a lot of diversity of different types of agriculture, and also the stakeholders. People always think of just the farmer, and of course that's the epicenter. But really, there's a constellation of actors, from input providers, equipment providers, labor, fertilizer, water, governments, markets, market influences, and all of those actors shape agriculture in its inception. And then, of course, you have the journey of agriculture through the supply chain before it becomes food on a plate. And so agriculture is really a pretty complex, vast, and in fact, not really even an industry. It's sort of a combination of a bunch of industries.
And more data makes a difference. The simplest data is what everybody sees is weather. What is the weather right now? And what is it going to be soon? And that affects whether plants grow, and that affects when you should apply fertilizer. It affects when bugs are going to come out. And if you can predict those and respond in advance or respond correctly, you will be able to grow things more cheaply and better, right? And
yeah,
so
that's in line with the thinking that we had about how do we provide tools to and information more broadly to a set of stakeholders in an open source type of way. The sort of opening of our discussion. And weather is a great example of that. So, a third of the food is wasted while a third of the people in the world are hungry. And so the supply chain is massively inefficient. And one of the many factors that contributes to that is the increasing volatility in and unpredictability of the weather. And, my grandfather used to say, farmers always looking up or looking down, no time to look sideways. So it's sort of one of those things that makes such a huge difference if you just have a little bit better forecast, or even if you know what the past weather has been. And it turns out that weather not only affects crops in a very real way, as people might understand fairly easily, but it also affects pests that have evolved alongside those vegetative fauna and flora, and those pest cycles, the reproductive cycles of invertebrates, it turns out are also affected by the same agronomic variables related to weather, things like degree days and chill hours. And so, yeah, it has a very, very tangible effect. And if you can get a handle of that, a very direct measure of improvement in efficiency.
But farmers can't run a weather access service. They can't go find the data. They're busy farming. And
yeah, it's one of those connected stakeholders. Yeah, exactly. So, any of these services are really hard for farmers to access. Most of these services are actually free. The data is free. It's hard to access by farmers. We're busy as we want them to, busy farming, right? So we want them to have very easy, sort of ubiquitous, frictionless access to this information at their location. So not just where you and I are, but where they are farming in that field. What's that situation look like? And very, very tangible actions. For example, when to plant a seed. The soil temperature and soil moisture have to be just right for germination to happen well. Those are very dependent on weather.
Yeah. And of course, somebody's just asked the clear question, is this weather or climate? And the answer, of course, is yes. And is much more as well. There's thousands of publicly available models. But what we've mentioned here is the problem that finding the data and applying it, if every farmer, and there are many millions in the world who do the farming, if every farmer had to do that work, we would have millions of times more effort than is reasonable. And if every small scale data supplier in a local region had to do it, there would be hundreds of thousands of times more effort applied to it. And so that's really where we come down with AgStack, isn't it? Where we are providing existing cloud-based capabilities which run and that provide this access so that the service providers in local settings can provide that data in a usable form. And it
really is.
Yeah.
Yeah, it really is. I think the idea is to kind of reduce the need to reinvent and retool the same thing over and over again by providing a host of, not just software, but services and data in a packaged and more usable way, so that data and that those services really can be shared across both content providers and easy for content consumers, which are the farmers and other stakeholders to consume. So yeah, the notion is to kind of take these sources of data, take some software and create services and value-added components, which I generally call digital infrastructure, for applications to become thinner, to become much more easy to build, much faster to build, much cheaper to build, and a whole host of applications, very different ones, might require the same reusable components. And if those components were free and were services, not just software, you could build those applications much faster, cheaper, and better, and then use them interoperably much faster, better, cheaper as well. And so that's
where open source avoids people having to re-implement the wheel.
Yeah, exactly. I mean,
it lets people not have to remeasure it. What we're doing is making it so people don't have to redeploy these services redundantly.
Exactly. I mean, the weather is a great example. I mean, a lot of what people are doing, from pest management to planting, as the two examples we just gave, both depend on weather. So if this infrastructure wasn't there, a pest management app or pest prediction app might have to build the same weather information service to inform the pest application or pest prediction as a planting application or planting prediction might have to. And those are two very different applications. And there are thousands more. And so by having these reusable components, which are in open source, but are more than software, those applications can be, very diverse applications can reuse these components and be faster, better, cheaper to market, while at the same time ensuring that the data has integrity, it is from a single source of truth, etc.
Okay, and so it isn't just weather though that we're doing, and it isn't just service. I mean, what we're doing is using open source and producing open source, right?
Yeah, so the idea is there's a whole host of things inside what we call digital infrastructure, all designed at the Linux Foundation with the open source paradigm. So the paradigm of open source is very much true, but it's much more than that. So for example, we have another project for an asset server where we're actually helping people register and then access the field boundary of a field anywhere on the planet in a way that allows a very, very lightweight registry to serve the needs of a whole lot of applications that then don't have to draw field boundaries in order to create a geospatial reference index or an address for a field. A lot of things like satellite data or weather or other data services that we talked about, you need a geospatial index or context handle to essentially access those. And that context handle can be essentially easily provided at scale without the need for every application to have to draw that field manually, which is a royal pain. And not to mention that the same field can be drawn by two different applications and called two different names. And when you have those separate data sets, if they were ever to be merged, you wouldn't know. Let's say a farmer wanted to merge their tractor data with their fertilizer data, you wouldn't know that they're the same field. One would call it field A, one would call it field 1 as an example, and how would you know that they're the same field? So by contextually georeferencing it, that infrastructure enables data sharing. And I think that is really something, is another example of that sort of infrastructure as a service, if you will.
Yeah, and I always have people get a little bit confused about the term asset. Asset doesn't necessarily refer to a financial asset. It's a thing on a farm, and largely the farm, the fields, right?
Yeah, we start with the fields. We call them assets because that's what farmers would call them. But essentially, or a bank would call them giving a loan to a farmer. But essentially an asset could be anything on a farm. It could be a tractor, it could be a well, it could be a water line ditch, it could be a gate. So it really is a broad term, but in the first order scheme of things, one could think of them as fields. Yeah.
Now, but so is there an official definition of a field that has to be used here?
Well, I mean, I don't know what you mean by official. What do you mean by official definition?
Yeah, really. That is the problem, isn't it? Is there's so many.
Yeah, exactly. So, you know, the sort of more intrinsic definition of a field is its boundary, right? When you think of a field, it's really geographically defined by a vector of lat longs that identify its boundary. And, you know, even that one could draw in infinite different ways around the same field. So, you know, the infrastructure has to make it somewhat smart, such that fields that are very similar, and there are a whole bunch of algorithms that could be used to kind of determine that, you know, if there are slight differences, but they're more or less the same field, those cases are dealt with. If it's a subset of a field, those cases are dealt with. And there are geospatial index open source, I would you know, hasten to add, ontologies, for example, the Google S2 schema that allows those kinds of nested geospatial, you know, algorithms to be designed really easily and quickly. And so we want to leverage what we already have in working in other domains of tech that tech is affecting, and use them or reuse them as much as possible for serving up these types of infrastructure components, which uniquely define a field, but also has some tolerance such that fields that are approximately the same kind of get the same name, if you will, or ID. And I think that's the closest definition of sort of what is the official, you know, ID for a field. You know, but it's a tricky situation. Yeah.
Yeah, and official ones, really official ones, aren't usable for a lot of things. Like
Well, that's
the
exactly
USDA
right.
has stuff in the US that can't be public.
Exactly. And it's always a little strange to me, but it turns out that, you know, the governments of many countries, US included, keep field boundary records for their own use and for all kinds of reasons, which many of them I don't understand. You know, they don't make them public. And when they do make them public, they're very hard to access. And when they are hard to access, they also come with a lot of other information, like who owns the field, or who has rights on the field. And those are all relevant and important questions. But at the heart of this, we're not trying to solve that problem. We're trying to solve the problem of what's the boundary of the field, because you need the boundary to get public data information, because it's a geospatial handle that addresses that public data from, say, satellite, you know, geotiffs. So yeah, it's the public data sources are really not helpful because they're meant to cater to assessor parcel maps, or they're meant to cater to you know, government specific work, which tends to be shrouded in some secrecy for some reason.
Oh, and a lot of times it includes private data, like who is it and where do they live, and things like that.
Yes, and we don't want necessarily that to be exposed. Exactly.
We don't want that kind of problem. So we're trying to build a public usable reference, a very open service, not just open source, but open service reference that people who own the land or use the land or are going to be delivering something to land can use, can create and use as a reference.
Yeah, exactly right. I think that in this example, it's a reference. More generally, what we're trying to do is to bring together, you know, data models as, you know, utilities and frameworks together into a usable components, really, that are in open source, are, you know, secure, they're neutral, we don't take anybody's side, they're really public domain information, but we make the friction go away or reduce it dramatically for using them and for building on top of them. And I think that's the nature of what we do. And the reason for that is very simple. If we were to do that, we can help really accelerate the innovation in this ecosystem, which is broadly, grossly inefficient because of the lack of information, not because of intent. And that acceleration can really help solve some of the major, huge challenges around water use, around climate change and affecting crop yields, urban migration. There are all kinds of things that are sort of interconnected in agri ecosystems can be dramatically positively impacted if this ecosystem were to accelerate in its adoption of digital technology.
So there's an irony here that we feel like we can have more effect by doing less, by having a service that doesn't have all of this private data, doesn't have what exactly you've done to your field included, so that our service is not hobbled by privacy concerns. And
well, yeah,
it's
right.
Weird, isn't it?
It is. And the interesting thing about that is also that it's when we explain to people what we do, because we are building sort of infrastructure, we deliberately stay away from applications. It's hard to imagine, kind of like how it's hard to imagine what an operating system does, right? Nobody really thinks actively about operating systems, but actually that's the major broker, yeah.
Well, some of us are geeks. And so what we're trying to do here is connect geeks with the real world.
Well, that's right. We need geeks. We need nerds for the real world, particularly in food and ag, particularly in climate. And if there's one thing that people could take away from this talk is that we need them.
Yeah.
And so that's the big issue here, is that in the world of tech, which I come from, you come from, we're so disconnected sometimes from our food and agriculture. We don't quite know where to start. Well, here's one place you can start. We need developers, we need tech folks, we need nerds, and we need them in abundance. We need a lot of them.
So we've had a number of questions on the chat. I've been kind of distracted answering them. But one of the key answers, by the way, is not an answer at all. I posted the invitation link for the AgStack Slack, so that, and I made a joke. I actually made a joke on the chat that the chat for this talk and this talk in general is short term. It's like the weather. The AgStack Slack is like climate. It's long term. And so that's really the place to go to have longer term discussions about this. We're going to keep talking about this today, but we'll keep talking about it over the next weeks and years on the Slack there. And I've seen already like 6 or 7 people have signed up for that Slack while we've been talking. It's kind of a kick to see real-time response like that. And so if we don't get to exactly the kind of question you have today, let's jump on Slack and have a discussion. Absolutely. Partly because it may be we don't have the answers. It may be that you can bring us the answer. And in fact, Dennis Miyoshi has a second question here. And he's talking about this system called GRASS, which is a publicly available GIS system that people can download and so on. And we'd love to participate in systems like that. But what we're trying to do is a little bit different, because GRASS is open source software. And so people can download it, they can run it. And what we're trying to do here is do open service, things that people can rely on because they run already. They don't have to download them, but they can get going on doing things that interface with people more. I know that here at HPE, we've been supporting a group called Digital Green for quite some time, who are out in the field, literally in the fields, working with farmers in local languages, building videos and things like that. And Digital Green is very enthused about using open services so that they can focus on providing direct services to farmers that are more advanced and more capable. So
just to add to that, Ted, I would just say that there's Digital Green is one of our members. We have constantly engaged with a lot of the farming community, but we need more participation, and we'd love to get more participation from the developer community. Yeah.
So they've mentioned that I have my notifications popping up all the time. Yeah, I'll do that. I'll try to close those down if I can figure out how to do that without sounding like I'm just saying while I'm doing it. So let's talk some more about, you've got this slide that talks about the interaction of what we're doing. The interaction, for instance, with weather and asset boundaries.
Yeah, so these components are not just components for applications by themselves, but they're also interoperable with each other to provide a more cohesive, as we say, digital infrastructure for these applications. So as an example of that, the weather server provides a forecast as well as a historical weather on a bunch of different metrics like temperature, humidity, et cetera, for a given geospatial location. So you give it a lat long and the server responds with the weather forecast for the next 7 days. And you can get it as a GeoJSON, or you can get it as a visual. And one of the key components, one of the key design elements of that is that it's location based. So, as it needs to be. So if you have a location which is a lat long, you can get the weather. Now, let's say you were in a field and you were building an asset boundary and created an asset boundary. By nature, by definition of having this geospatial boundary, the context handle has the location. So essentially, by using the boundaries ID, which hashes to a location, we can actually make the service automatically provide weather for a field. Because the field boundary automatically already has its geospatial boundary built into its ID, it automatically receives weather. So anywhere you're using these boundaries, not only do you get the boundary itself for free, because it has been pre-registered, but you also get the weather for that boundary. And you can do what you want with that hourly weather forecast. You can do pest predictions, you can do planting, you can do when to harvest, you can do all kinds of things. And so that's becomes the sort of, ways to interconnect. Geospatial and temporal handles are a really good way to sort of connect these different services components so that when you get one, you get the benefits of the other. Same thing with the collaboration framework, which is a message bus really, which has been purposed to automatically locate and tag the asset boundary from which the message was sent or to which the message is sent. So fields can send a message, people on fields or field sensors can send messages tagged specifically to fields. And when the message is sent from a field, automatically that message, let's say you saw a particular pest and bug, and you were measuring the number of bugs in a trap, which is what Ag Extension typically does, it would automatically reference the weather and create, access a degree day model that could use that weather for that location. So all these services kind of have interconnective kind of design by intention, such that they can be used together, even though they're useful by themselves. Ted, you're muted out.
Yeah, I was muted for those nasty little notifications and then forgot to unmute. It isn't just one thing. It's an ecosystem, a network of services that connect together and start to provide higher and higher value. But we want to also connect with a bigger ecosystem of local providers who understand the needs of farmers in their region. So here in California, people grow rice. but they do it differently than they do in India or Vietnam. And so their needs are going to be different.
Very different. In fact, I would say that's an explicit design goal that we have at AgStack, that we're not really there to necessarily dictate. We're there to offer some examples, but really it's to help the experts or the people who are designing these innovations, whether they're in big companies or small companies or startups, to really build their tools, their advisory services, their offerings in the private sector, as well as government sector, more efficiently and faster and cheaper. And really, the primary motive is to sort of really provide this big boost to the startup ecosystem, which is alive and well. And it's one of the shining stars of hope for rural ecosystems, where digital hasn't quite made it. It's a big digital divide in some rural ecosystems, even in developed countries, but particularly in developing countries, that if the local talent there, and there is a lot of local talent, can easily develop applications to solve their own local problems with help from open source services and infrastructure that reduce the time, reduce the cost, and make a quick access to these services available to them, that changes the game. Because we can't even imagine, we definitely cannot imagine all the ways in which different problems manifest themselves in different places in the world. The people in those locations are best equipped to solve those problems. What we're trying to do is make it easier for them to solve those problems, cheaper, easier, better.
And we're talking about a lot of people. So there's like more than 100 million farmers in India alone. And even there, the things are highly variable. And so there's a huge amount of resources there that are being hobbled by difficulties which are repeated.
Yeah, it's something that gets lost sometimes in an urban ecosphere that we live in, that half the world's population is employed directly or indirectly in agribusiness. And so it's really phenomenal number of people in the world that are involved in this ecosystem, which also, by the way, consumes 70% of all fresh water in the world. And so if you look at that ecosystem, you say, how big is it? It's the mother of all ecosystems in some ways, and it's existential. This is not something that is a nice to have. It's a need to have. It provides livelihoods. It provides a way of life to billions. And so really, there are a lot of people who are affected by this and will be affected by this. Yes.
And it, just as a personal note as to how little I knew, even though I thought I knew a lot, I didn't realize that a very large fraction of farmers in the world, but it's local and different, are women.
Very true. In fact, in different countries, it's the demographic, the gender demographic is slightly different depending on cultural values. But for example, in Africa, the majority is women. And increasingly in some parts of India, the majority is women. It depends on the type of farming, and it depends on the type of ecosphere that they are, but absolutely.
So one of the pressures that I've heard about is that guys can take factory jobs sometimes more easily than women. And so they'll go off to the factory and the women will be doing the farming. And that's
and it's also, it's that for sure, that there's definitely that's one of the use cases. Another one that I've seen personally, like in my own family, my extended family in India, in my village, the men go to the fields, the women milk the cows. I mean, both of them are agriculturally, intensive. Anybody who's milked cows will tell you it's not an easy job. It's very tough. It's a tough job. You have to wake up early morning. You have to do all kinds of things. The milk is like the last great byproduct of a whole series of things. But Nestle buys $2 billion worth of milk from farmers, often with 1 or 2 cows in India. And those farmers are mostly women who are milking these cows. Yeah.
I have a lot of respect for that. As a kid, I visited farms from friends and stuff, and I failed to milk a cow several times. I got
Oh,
kicked
yeah.
and I could
The cow
not
will
do
tell
it.
you. The cow will tell you don't know what you're doing. Yeah, for sure.
And the cow was very emphatic about that, and they were right. And so
Yeah.
it's all going to be different. And so we need the innovation of those hundreds of millions and billions of people doing
Yeah, it's mobile
agriculture.
first. Yes, exactly. It's mobile first. It's low bandwidth ecosystems. Those are the ecosystems we're trying to affect. And the more of this open source stack of services, data, things that they have for free, and things that actually work, the quicker, faster, cheaper they can make that innovation happen specifically for their area and their ecosystem. And
the more that we simplify the finding of this stuff and focus it in on an agriculturally specific deliverable service.
That's right. That's actually very important what you just said. Agriculturally specific. A lot of things are available horizontally, but they're not, they need to be custom tailored just slightly so, or sometimes subtle, but very importantly so, to make it relevant for agricultural things. And that's what we're focused on doing. We're not looking to reinvent anything. So yeah, for sure.
Yeah, I remember when we were working on the weather server, the weather data is all available.
Yeah.
And it's beautifully done.
Yeah.
But it's weird. The primary file format was invented in the 1980s.
Yeah.
And so you have to have special software to access it. And then you have to have special software to index it. And I can't imagine that being done a million times across the world in local languages. That needs to be done once in a global sense and made available in a modern, service-oriented, web-accessible kind of way.
Exactly.
And that was what we worked on. But it was amazing to me how available and at the same time unavailable that data was.
Yes. I would use the word available and inaccessible. I think that it's, making something available isn't necessarily making it accessible. And so I think, our job at the Linux Foundation and AgStack, with our help of our partners and members like HPE and Digital Green and others, is to really take that challenge head on and say, we're going to make it more accessible. We're going to make it more context relevant. We're going to make it such that it's easily understood. And the more we focus on easy and low friction, the better off I think we will be at sort of accelerating the pace of innovation, which is exciting to see, and it's dramatically needed.
And we've got a number of people joining the Slack. By the way, we would like to make it easy to contribute there. Anybody popping in, having a question is contributing, because we don't always even know the questions to ask. And
that's
anybody
exactly right.
who drops in and tweets about this is contributing. Now, if you have skills and you want to lay them down and do some serious work, that's contributing in a different way. But there are lots of ways to contribute, and a lot of them are real easy. And if we get a lot of people doing easy stuff, a moderate number of people doing the harder stuff, then we can literally change the world for the better here.
Yeah, and just to echo some points that you made, Ted, I think everybody says this, but it actually is very true in this ecosystem for sure, because there's this proverbial story about the 6 blind men touching the elephant. Nobody got the elephant's consent, I guess, in that story, but the idea here is that all of them are right. One person touches the stomach, says, "Oh, it looks like a wall," and one person touches the tail, says, "Oh, it looks like a broom." But they're all wrong. None of them see that it's an elephant. And this is that magnified a million times, where the more of the ecosystem and the more we get people to sort of provide different perspectives around building this infrastructure to make it frictionless, the better off we will be at understanding what is it that we ought to be building. I mean, we have an originating hypothesis, but that doesn't necessarily mean we're right. That doesn't even necessarily mean we're on the right path. It could very well be that people will come up and say, have you thought about this? And I would say, probably not. We probably haven't. And, every time I think I know what I'm doing, I get to talk to somebody in our community and I realize I don't.
So could you say a little bit about the pest and disease management?
Yeah, sure. So, just to start with an anecdotal example, tomato yields in California are about 50 tons to an acre on average. They can range between 40 and 80, but let's say 50, 60 tons per acre. The same variety of tomatoes that are bought by Heinz in India, same variety, are 1/5 that, 1/5. So 10 tons, 8 tons, yeah, 5 to 8 tons per acre. A lot of that is because of pest pressure. And so what ends up happening is that because India is a tropical country compared to temperate, relatively dry California, you have a lot more pests. And increasingly farmers are being incentivized and are aware of using less chemical loading. It's also economically beneficial. So the more you can be very precise as to when the pests might be coming, the better you will be at timing the intervention that you might have. So for example, in India, people use this neem. Neem is I don't know what the scientific name is, but it's the name of a tree that produces the antibacterial leaves. And so you make a paste of those leaves and you soak them in water. It creates for fantastic, non-chemical organic pest repellent. Now, when do you apply that pest repellent is all dependent on weather. So for example, if you are able to predict the humidity level and the leaf wetness duration and the degree days of the 17 different pests that attack tomatoes, which are, by the way, all characterized by many universities in the world, from University of California here in Davis to the Agriculture University in Punjab, all have pest models for taking degree days and predicting pest pressure. What is the probability of that particular pest being manifesting there? If you can build an application to take that weather, use the pest model, and build an application that creates pest pressure prediction for a given field, you can then be smart about when to apply that intervention. And by doing so, increase yields, maybe not as much as California, but even if you went a third of the way up, that's straight money into the pocket of that farmer. All the other costs are the same. That comes straight down to the bottom line. And that, I think, is the types of things we want to imagine improving. So as an example of that, if we take the weather data, and one of the things we didn't talk about is we're creating a models repository. It was in one of my slides here, where different Python models for predicting these degree days can be instantiated with the weather data. So any application can sort of say, oh, what are the library of models for tomatoes? They can quickly look up the model. If they want to make a change, they can. It's permissively licensed. And essentially, they have then the degree days for a field, which is on a mobile phone instantiated by the user. That model gets instantiated for that weather, for that field, and you know what the prediction is. And in fact, you can apply a language filter and even translate that in the local language. That's the kind of stuff that we think, and by the way, these pest and disease models are in abundant, they're abundantly available. Thousands are available already. They just need to be codified into Python. We need to build a repository and we need to instantiate weather. That's all that we need to do. And so that's pest and disease management infrastructure that can then enable thousands, if not more, applications who are going after different types of crops or different types of aspects to pests. Pest modeling isn't just about when to apply pest repellent. It's maybe also to sort of think about, what seeds to use that are less susceptible, the varieties that are less susceptible to certain pests. And so the more information people can have through these applications, the better, more informed they will be in increasing that yield from 5 to 8 tons per acre to 50 tons per acre.
And it isn't just pests, of course, it's growth models for the plants themselves.
That's right, exactly. And that's, I think they work together. So the phenological models of pests are kind of a cousin to a phenological model of different plants. And so the same models that apply to pests, the same sort of modeling framework that applies to pests, different models in that same framework can apply to plants. And so there's an entire model repo that we can create, which are all weather dependent. And all these are field dependent. And so you can see those tie-ins with the asset boundary, the weather, and now these models all coming together. And in fact, you can start doing pub sub and messaging on certain pests. Hey, I just saw a pest, take a picture. That pest automatically resolves to an ag extension person who says, oh, this pest is so and so. As soon as you say that, there's a degree day model that gets selected, and sort of those kinds of things can start to happen.
This is crazy making because there's so much available out there. And it's just connect A to B.
Yes, exactly. And I've spent so much time thinking about this just in California and India, but when you start talking to people in other countries, you see such incredible innovations that they could do if just they had some pieces available for free. And that's kind of what we want to do. Free and open source, free in the sense of libre, not just gratis.
And free in the sense of service, not just source.
Correct.
Okay, well, this is funny. I've been working with you on this for I think it's over a year now.
Yeah.
And just talking about it again blows my mind at how much there is that we can do.
Oh.
And how much there is to do, and how much different people could, wow, just so much to do, so much good that we could do.
Oh, yes. And, companies like Digital Green, for example, that are at the last mile, that we just had another member join us, Heifer International, which is a big NGO. They work in 22 countries. They are also like Digital Green at the last mile. And, they're working with farmers, and their whole thing is capacity building at the village. So they're not just doing agriculture, they're doing all kinds of other things as well. But ag tends to be the sort of heart of it. I mean, they're so excited because they're like, look, anything you can do, we can have farmer cooperatives, create some sort of aggregated digital skilling to make, tens of thousands of farmers in one cooperative being able to use these tools. So, you have the sort of last yard cooperative ecosystem that is thriving all over the world. And so we actually have partners who can implement these things at scale. So it's really exciting. It's just about exactly what you said, that's connecting the wires. And again, shameless plug to the, developer community. We need you. We need you.
And it isn't obscure stuff. A lot of it is fairly straightforward, at least for people with, different skills. So we don't have to know all the local languages or how to put water on these plants. We just need to know how to code. And our partners will help with the final mile. We also have partners on the first mile. We support research at, for instance, CGIAR, and everybody in the US supports a whole ton of research through the USDA and other forms indirectly. And so we're trying to connect some of the dots, not all the dots, just some crucial dots.
For sure. I mean, recently, for example, I was speaking to a scientist at NASA JPL, Jet Propulsion Laboratory, and they're building carbon models for looking at net carbon flux coming off of the terrestrial surface. And he and I were talking about how can we make these carbon models specific to a field so that farmers can get carbon credits. I mean, that's not very far away. So I think that the future is exciting. It's very possible and real to affect it with real, digital fabric, real digital tools and services. And we're excited about what we're doing and want to, ask for people to contribute.
This is grand. We see DDA popping up. We've got 2 minutes left. Any last thoughts that we need to close with?
I'm going to launch the end of session poll for people to give us their feedback. I think that was really interesting. I was browsing the Slack channel myself, and yes, there's a lot of things that we can do there, and I'm sure you'll find some geeks and nerds to join there.
And that poll is 3 questions. It's not hard.
No,
But I can't vote because hosts and panelists can't vote. So I'd really appreciate it if you guys would.
So yes, thank you very much, Sumer and Ted. I think that was a great session, very interactive. We got a few interesting questions, and I think people understood that there is interesting things that can be done.
And I'm going to paste the link to the Slack into the chat one last time. There it is. We look forward to seeing you folks over there if you got some moments.
Thank you, DDA. Thank you, Dale. Thank you, Tad, for hosting me, and really enjoyed the conversation, and look forward to collaborating on our Slack channel.
Thank you.
And thank you, Samir, for organizing this. This has been really fun to work on.
My pleasure.
Thank you, both of you. And thanks everyone for joining. Give us your feedback before you leave. Thank you very much.
Thank you.
Thank you.